Chapter 5.3, we're graphing radical functions. So a radical function contains a radical expression with the independent variable in the radical. So when the radical is a square root, the function is called a square root function. So square root, so you just see the square root of x. When the radical is a cube root function, the function is called a cube root function. So therefore it's cube root of x. That's what we would see. So let's graph the parent function for square root and cube root function. So the parent function is f of x equals square root of x. So let's think about some numbers to plug in here. Square root of x. So what x value? And then this is square root of x. And what do we get? So what's the lowest x value we can pick for here? Well, 0, because square root of 0 is 0. Then what's another good number? 1. Square root of 1 is 1, so that's good. Then thinking about the square root, what's another good number to choose? 4. The reason that's good is because square root of 4 is 2. Then the next number would be 9, because square root of 9 is 3. So it works out really nicely. So let's graph this. 0, 0, 1, 1, 4, 2, and 9, 3. So can I ever pick any negative numbers here? I can't, because remember that you're not allowed to have negative in the square root, right, as the final answer. So here is our graph. Another thing that I want you to notice is that there is a pattern. If I start here, I go up 1, right 1, up 1, right 3, up 1, right 5. So that kind of should remind us of our parabolas, okay, a little bit. All right, let's look at the domain. Domain is the lowest x, domain is the x values, and so now let's take a look at what is the lowest x value. Our lowest x value is 0. And then it goes to infinity, right? Because it goes to forever to the right. So it's 0 to infinity. The range, the lowest y value is still 0. And then it goes forever up, which means that the range is 0 to infinity. Square root functions have even indexes. Okay, even index. So that anything with an even index is going to look similar to this. Let's look at a cube root function. So cube root, the parent function of that is f of x equals cube root of x. So let's think about some numbers to plug in for cube root of x. So I can plug in, just writing it here, I can plug in 0. Cube root of 0 is 0, so that's good. 1, cube root of 1 is 1. Can I plug in negative 1? I can. Remember, it's odd. I can plug in a negative 1 because that is negative 1. Remember, with cube root of negative 1, I can do negative 1 times negative 1 times negative 1, and that is a negative 1, right? 3 negatives still equal a negative. So that works. Thinking about the cube root, what's another great number to choose? What's perfect? 8. Cube root of 8. What is cube root of 8? Cube root of 8 is 2. We could also pick negative 8 because cube root of negative 8 is a negative 2. So now let's graph it. So we know 0, 0 was good, and then 1, 1, and then negative 1, negative 1, and the next one is 8 because cube root of 8 is 2. Cube root of negative 8 is negative 2. And so this is what the graph looks like. Domain and range. So notice that it goes forever to the left, right? Arrow to the left. That means negative infinity. And then down, right? Also negative infinity. Then it goes to the right forever and up forever. My y's are continually increasing. My x's are continually increasing. So therefore, it is negative infinity to infinity for domain and range. Cube root functions have odd indexes. Okay, they're odd indexes. All right, and then after that, you will be able to graph some of these. And so, but that's the basics for for graphing radical functions.